So today we actually first introduced this idea of trig ratios in class. Right now we're going to take it a little bit further. We're going to start with some things that we talked about in class already. So just to kind of, again, recap, make sure we're good. But then we're going to take it a little bit further. Having your calculator out would be a good thing for today because our calculator is going to be a great tool. Okay, this is going to be pretty hard to do without a calculator on some of these things, okay?
Yes.
So some of those that don't have their calculator on a regular basis, this is not one you want to do that with, okay?
Yes.
All right, so we're going to start with let's find the sine, cosine, and tangent ratios of angle T and angle H. Okay, now again, reminder, right, something that might help. What is that?
SOHCAHTOA.
Now, what ratios basically mean is you're talking about comparing two sides. And in this case, you're talking about two sides in one triangle.
Right.
Sine, cosine, tangent ratios are within one right triangle,
yeah.
All right. And notice this when they say of angle T and of angle H, those are the two acute angles, and those are kind of your reference point. Okay. So if you're saying we're starting with angle T. All right. If we're doing the sine ratio, now sine ratio basically is saying
to take the opposite over the hypotenuse.
Okay. So if you're looking at angle T, what is the opposite side?
The side opposite would be our 4, that FH. Over the hypotenuse, which is the 5.
Now, we talked about just leaving it in a ratio form, okay? Now, when we're dealing with trig ratios, a lot of times they're going to ask you to give a decimal answer off of that, okay?
Right.
And we talked about rounding, if we had to how many decimal places?
4 decimal places.
4 decimal places. So that's a little bit different than one more normal. So 4 over 5 actually is exactly 0.8. So it's not a rounded answer, okay? All right, cosine T. So cosine
is going to be the adjacent over the hypotenuse.
So what's the adjacent side in reference to angle T?
The 3. And the hypotenuse is still 5.
And that equals, when you put that in your calculator, 0.6.
0.6.
And that's exact. All right, last one. Tangent of angle T.
All right, so tangent is opposite over adjacent. So the opposite was the 4, and the adjacent was the 3.
And when you put this in your calculator, this one would be a rounded answer.
Yes.
And it's going to be
1.3333, because it's 1.3 repeating, but the fifth 3 will not round the fourth 3 to anything higher.
Yes.
Okay.
So there's your approximate there, okay? All right, let's go with the other trig, or the other angle, and find all the sine, cosine, tangent ratio of that. So again, sine at angle H this time. All right, if we're doing angle H, let me get rid of that. Angle H in reference to that, so sine is opposite over hypotenuse, so what would that be?
So the opposite of H would be the 3. The hypotenuse is still the 5.
That sounds kind of like we had said before, so some of you might be noticing something we mentioned earlier today. Cosine of H?
That's going to be our 4 over 5. So there's our 0.8.
And tangent of H?
The tangent of H, we want to take the opposite over adjacent, so 3 over 4.
And that would be?
0.75.
0.75. Okay, so something, we've already mentioned this, but I want you to kind of soak in what we've talked about today, and also on this slide, some things that we're noticing. All right, on the next slide, we're going to kind of jot those ideas down. So what are some things you're noticing about these trig ratios? You know, think about the sine ratios, cosine ratios, tangent ratios.
So like the sine of one angle is the same as the cosine of the other acute angle.
Okay, so the sine of one angle, of one acute angle, so like the sine of T was equal to the
cosine of H.
So these were equal to each other, and vice versa.
Same thing with cosine of T. Yeah, and sine
are equal to that. Okay, let me go to that slide real quick. So what are you noticing at the sine and cosine ratios? So the sine
of one acute angle is equal to the cosine of the other acute angle.
Okay, now I want to go back to the sine and cosine. That's definitely a good thing, and that's helpful because if you find the sine and cosine of one acute angle, then you know the sine and cosine of the other, okay?
Right.
It's pretty easy to do. I want you to notice also the values in the end, okay? When we went ahead and put in our calculator, what do you notice about those values?
Well, they're all decimals. They're all less than a whole.
They're less than a whole.
That's really the key.
And actually not less than a whole, less than one exactly whole, okay?
Yeah.
Not any whole.
Right,
any
less
whole
than
number,
one. Sorry.
less than one, okay? Because, and notice, and there's a reason why, okay? What are you comparing with a sine and cosine?
You're always comparing something to the hypotenuse, and the hypotenuse is always the longest side. So when you write a fraction where it's something compared to a longer piece, it's always going to be less than
and
one.
And just look at your ratios. They're all small to large, small to large. So that's another thing. So these are always
less than one.
Less than one, okay? And that's because you're always comparing a smaller number, okay, small number, to the larger with the hypotenuse, okay? You're always comparing basically a leg, if you think about it. Maybe I should write that. The leg to a hypotenuse, because it's either the adjacent or the opposite leg, okay? So something to keep in mind. All right, what about tangent ratios?
Well, looking at the actual ratios, they are reciprocals.
Ah, I like that. Why do you think that's the case? Does that just happen on this one, or is this always going to happen? Think about what you're comparing with the tangent
because
ratio.
one's opposite is the other one's is adjacent. Yeah. So when you're doing an opposite over adjacent, it's really the other one's adjacent over.
They flip-flop it, right?
They flip-flop it,
because you're always comparing in the tangent the two legs.
Right.
And it's going to be one on top of the other. So I'm going to make a little note, right, for tangents. So the tangent ratios basically are reciprocals.
And I like that you're leaving it tangent ratios, because really that has to be comparing the ratios, not the decimals. But the tangent ratios are the reciprocals.
And again, the reason why is because you're comparing a leg to a leg. You're not comparing with the hypotenuse with this one, right? Now, going back, let's talk about not the actual ratio. Well, it is the ratio, but the decimal version of it, okay? So we notice with sine and cosine, they're all less than one.
Okay, I see it's true for this one, and it would make sense. If they're reciprocals, one is going to be greater than a whole. One will be less than a whole.
So greater than one, but less than one, or
and
less than one.
And the only way that they wouldn't be would be if it was a 45, 45, 90, because those two legs would be equivalent, so it would give you just one.
Exactly one. So tangent ratios can be greater than one, or they can also be less than one. All right, so it's just one or the other.
Or equal to one.
Also, or equal one. And when that happens, that's in a 45, 45, 90 triangle because of the fact that they're going to be isosceles.
So they'll be two equivalent values.
So some things to be aware of. Why is this helpful? Bottom line, guys, when you start getting answers and you're like, okay, well, I know this is going to be reciprocal of that, or this is going to equal that, or if I get, the big thing I see a lot of times is people will they type in their calculator wrong, right? And they get an answer that is larger than one for the sine ratio. That's never going to happen.
Right. Okay? So it's just some good logic to be thinking about.
Speaking of good logic, this next slide is just another kind of way to check, right?
Right.
To me, I mean, you don't necessarily need to memorize these trig identities, but what's nice about it is you could check, okay, does the sine ratio squared plus the cosine ratio squared actually equal 1? So if I look back at that last example, what was the sine ratio again?
It was a
4/5,
and then the cosine was
3/5, right?
3/5, yeah.
If I square both of those, right, so this would be 16/25, and then, 9/25? I add those together, that's 25 over 25, that equals 1.
Right.
So it's a way to check. You can check with your calculator even, okay?
Yeah.
And then the second trig identity is the tangent ratio is always the sine ratio divided by the cosine ratio. So if I check that, the sine ratio was 4/5, and if I'm dividing,
you're really multiplying by its
3/5
reciprocal.
is the same thing as saying 4/5 times, what's the reciprocal?
5/3.
And when I do that, notice what I end up with is 4/3, because these will kind of cancel out, which is the tangent ratio.
Because that's really eliminating the two hypotenuse, and it's comparing the legs.
Now, again, if you're asking, well, what's the point of knowing these? It's more, to me, and I know Ms. Hooker, it's more of a checking purpose.
Yes.
See, did I really do it right? Okay?
All right.
Okay.
So we've got some problems that we want to just take a look at some examples together, make sure we can find the sine, cosine, and tangent, and we're going to round to the nearest 4 decimal places. We're used to doing this by now. And we are going to find for, on this one, angle R.
Okay.
So we're going to do the sine, cosine, and tangent of angle R. What do you notice about this one, too?
Well, they actually, in this one, they're actually giving you the measurement of angle R.
Uh-huh.
So that might be something we might need to know maybe later on. We'll talk about it. But I also know that it's a special right triangle, right? That's a 30, 60, 90 triangle. So some things that we can kind of hit on as well.
Right. Okay, so for right now, let's do what we're used to doing.
Okay.
Okay, and let's write out, and if it helps to write SOHCAHTOA out, guys, I usually write that at the top of my paper. And that way I have it to reference throughout the whole time that I'm working. But if we think about SOHCAHTOA, the sine of R, we know we want to take our opposite over hypotenuse, so what am I going to write?
It'd be 15 over 10 radical 3.
All right. Now, because we're going to get decimal values here, I'm not going to be super picky about you simplifying the radicals. But
agree.
here's what I want you guys to be careful with.
Yes.
When you are dividing and you notice that you have multiple pieces in your denominator, you need to be uber careful, because if I type in my calculator 15 divided by 10 radical 3, my calculator knows the order of operations that I'm trying to, not what I'm trying to tell it, but what it knows is that it's going to do division before it does any multiplication. So if you're going to type this in your calculator without simplifying a radical to where you're going to have multiple pieces in that denominator, you have to use parentheses.
Yes.
Okay, cannot emphasize that enough.
Yes.
Have to use parentheses.
And guys, these are the ones people miss all the time.
All the time.
Because they just don't know how to type it in their calculator. Okay? So when you type it in your calculator, you end up with about 0.8660.
All right.
And if you did not get that, then there's something wrong with your or you're not wrong with your calculator, I should say.
Wrong with the calculator operator.
Okay, so if you're struggling with this, tomorrow in class would be a good time to ask questions. The other thing I noticed that number is less than 1, which is a good sign because it needs to be less than 1 because it's a sine ratio.
Right. Okay, let's take a look at the cosine. We know we want our adjacent over hypotenuse. So in this case, I'm going to write what?
5 radical 3 over 10 radical 3.
So again, need the parentheses around the 10 radical 3. And be careful because it'll start a parenthesis here also. Make sure you close them.
And up top too.
And, oh yeah, that's the other one that people will mess up on this one. When you start a radical, your calculator starts that parenthesis. You have to close that parenthesis before you hit divide. All right?
Yes.
Now, what do we approximately get?
Well, this is going to be exactly 0.5.
Oh, that's right. This one is exact.
Now, the other thing while she's writing down, one thing you could also notice how there's a radical 3 on top and bottom, so those could cancel out.
Right.
But, again, guys, if you're using your calculator, because I know we love that calculator, right, and you're going to like it for trig, be careful. The calculator will do exactly what you tell it. You better tell it right.
And you could have, if you simplify your radicals first, you won't make as many mistakes. But we just know that a lot of people don't like to simplify their radicals, which we're just trying to emphasize. It's okay as long as you're careful with the parentheses. Okay. What about tangent of R?
All right, so it's opposite over adjacent. So 15 over 5 radical 3. So again, make sure you put parentheses around that bottom part. And that is about 1.7321. And again, notice my sine and cosine ratios are both less than 1. My tangent ratio in this case is bigger than 1. That's because I compared a bigger side to a smaller side.
Right.
Okay.
And that's okay.
And you could check it. Does the sine ratio squared plus the cosine ratio squared equal the tangent ratio? There's all these things that you could do.
Definitely. Now, what I want you guys to notice about this one is they did give us angle measures. So let's go back for a minute, because this was like really saying the sine of this R is representing that angle, because that's the vertex of that angle. That's how we name it. So this is really the same as the sine of 60. Now, I've had several people that yesterday probably mentioned to me that earlier today in class, not yesterday, today in class, that mentioned to me, so is this where these buttons come into play on my calculator? And here's where they come into play.
Yes.
I want you guys to get out your calculator and type in sine of 60.
Now make sure, and most of your calculators will have this, but make sure your calculator's in degree mode. Now if you have a graphing calculator, its default is not degree. Yes. Right? It is in radian mode. So you might have to go to the mode and change it to degree.
So if you type in sine of 60 and you do not get what we get, then you need to go to your mode setting and check that. Okay, when you type in sine 60 in your calculator, what does it give you?
It gives you the 0.8660.
Yeah,
now,
isn't that pretty cool?
Why is that? Why does that work every single time? Okay, is it because of the fact, to think about earlier today, all 30, 60, 90 triangles are similar to each other. So they're all going to have the same sine ratio, cosine ratio, tangent ratio.
Equivalent.
To when you're talking about that, okay? That their ratios will all end up being the same exact value.
Same decimal value, yeah. So when you type in the cosine of 60, we end up with?
0.5.
0.5. And when you type in the tangent of 60, we end up with?
The 1.732.
Perfect.
1.
Now, just to kind of see where maybe some of these other things that we've looked at today come into play, what if I did the sine of 30? I'm not even going to write the ratio, but what should be true?
It should be the same thing as the cosine of 60.
So was it?
And it is. It's 0.5.
You get 0.5. So kind of cool to see how these things come into play.
Yeah.
You can use your calculator to get these decimals. They just don't give you the ratios.
Yeah.
So when you're asked to find the ratios, you are going to actually have to know SOHCAHTOA to come up with the opposite and the hypotenuse or this opposite and adjacent or whatever pieces you're finding. But when they ask for just what's the decimal equivalent, we can get there.
And those exactly
if we have the angle.
Those represent what the actual ratio would not essentially simplify down, but become as a decimal.
Yeah. Kind of cool stuff.
Okay, so this slide is just a reminder again. Again, make sure your calculation degree mode. Most of the time you type it in, it's the sign button, and then you enter the degree amount. Or there's some calculators out there you have to type in the degree, then the trig ratio function. Most of you are going to have the one in the yellow, okay? Yeah. Most of the calculators are that way. Even graphing calculators are that way. Again, when you type in that particular trig function, what follows is the degree amount, okay? So you type in the sine, cosine, tangent, and then it's the degree because you're talking about in reference to that particular angle.
Right, and we've been saying of the acute angles, to find the sine of the acute angle. So you're finding the sine, we just know the degree of that angle here.
So let's get practice with the calculator. I want you guys to answer this slide without us. So get comfortable with your calculator, just find sine, cosine, tangent ratio of the 82-degree angle, and then do the same trig ratios with the 52-degree or 54-degree angle, okay?
Okay, so for sine of 82, you should have gotten the decimal of 0.9903. Cosine of 82, you should have gotten a 0.1392. And tangent of 82 would be a 7.1154.
Now, one thing to notice, how the tangent of 82 is really, really a lot bigger than we've normally. That's because you're talking about an 82-degree angle, and the opposite side of an 82-degree angle is going to be pretty large.
Right.
Okay, so you're comparing a pretty large number to a smaller one, so something to notice.
Yeah, okay? Especially when, you know, the three all together add to equal 180, and you've got a 90-degree in there. That's not leaving you with very much.
And notice how she's also saying this, guys. She's not saying sin of 54, cos of 54. All right? These are abbreviations, but we still say it.
Say the words
correctly, okay?
So the sine of 54 is about 0.8090.
0.8090.
The cosine of 54 is about 0.5878. And tangent of 54 is about 1.3764. So hopefully we're feeling pretty good with the calculator.
Okay. All right, let's just keep going on this one.
Sounds good.
Now, here's where trig ratios really come into play. We have learned about how to find missing side lengths of a triangle by a variety of ways. We've used Pythagorean theorem. We've used special right triangles. We've used, what else have we used? Similar right triangles.
Yeah.
Okay. So all these different options. Trig is a super convenient way, but you have to have certain things to be able to do it. Okay. Now, notice here, I give you a right triangle, and I'm only giving you one side, and I'm asking you to find the other two. Can we use Pythagorean theorem?
No, because I'd have to have two knowns and only one unknown.
Is this a special right triangle?
No, because it's a 3.5 degree. That's a
No,
little itty bitty
itty bitty
angle.
angle. Again, not drawn to scale.
Definitely not.
And it's not, there's not special or similar right triangles because there's only one right triangle. So
And
that
no
means
altitude drawn.
trig is our go-to. Okay, we have to use trig. We can't use anything else. So this is how we go about it. Okay, if we're finding x and y, okay, it doesn't matter which one you want to find first. Let's say we're finding x first in that order, right? Notice x in relationship to the acute angle they give you is what in relationship to that?
It's the adjacent.
It's the adjacent. And then notice the side they are giving you is what?
Is the opposite.
Opposite. Now, what trig ratio involves opposite over or opposite and adjacent?
The tangent.
Okay, so I'm going to set up using the tangent ratio. Okay, so I'm using tangent ratio. And how I'm going to do it, it's always the tangent of that angle. Now, they don't have a name for that angle, but they do give you the degree.
Which is even better.
So we're going to say the tangent of 3.5. And we're going to say that is equal to the opposite over adjacent. What is the opposite?
The 12. And the adjacent is our x.
Now, this is just solving an equation, okay?
Okay.
Now, there's a couple ways you could approach it, okay? You think about just trying to get x by itself. What's another thing you could think about?
I could put that tangent of 3.5 over 1 and make a proportion out of it and cross multiply.
And then just cross multiply. Now, this is what you're going to do. You're going to cross multiply and do x times the tangent of 3.5.
And one thing I want you guys to notice how she wrote that. She put the x first because you don't want to say the tangent of 3.5x because then we think that all of a sudden that we don't know the angle measure anymore.
3.5 tangent 3.5 stays together. It's one thing. It's going to get you one decimal value, all right? And then 1 times 12 is 12. Now, how do I get the x by itself?
We are going to divide by the tangent of 3.5.
And again, calculator, it's going to be super convenient. When you type 12 divided by the tangent of 3.5, and we said round to the nearest tenth, so what is that about?
196.2.
And guys, think about that. It's pretty darn large because this is a really, really tiny angle across from 12. So it's got to be quite a bit larger than that 12. All right?
Which this definitely
is. Now, that's only x. We want to find y. How are we going to go about doing that?
Okay, now for y, I noticed that I need to find the hypotenuse. So I'm either going to use sine or cosine.
Okay.
If I use, let's say cosine real quick.
Okay.
Cosine would be the adjacent over the hypotenuse, which I do now have that, but I know that I rounded that number big time to be able to get there. So I don't necessarily want to use the x value that I've just come up with if I don't have to.
I agree.
Because it's very rounded.
Okay.
And I even rounded the tenth, so like it's not very exact at all.
Yes.
So let's maybe go with sine because I have the exact opposite.
So we're going to use a sine ratio for what to find y because it's the opposite over the hypotenuse.
Right, and I'm given the hypotenuse,
Okay.
or I'm given the opposite, so I know that that's...
So we'd set it up, sine of
3.5 is equal to our 12 over y.
Okay, so we could do a proportion idea. Now, another thing I want to just kind of stress is remember back to when we dealt with proportions, you can rewrite proportions, okay? You could do like flip-flop of things, right?
Right.
Reciprocals. You could switch the means. You could even switch the extremes. So notice if I switch these, notice what happens. You get y over 1, which is just y, and then 12 over sine of 3.5. And then you just type that in the calculator. And that's what happened here. If you just switch these, you just have 12 over tangent of 3.5. That's kind of nice. Do you have to know that? No, it's just, it allows you not to have to do little cross multiplying and dividing. You're doing the same thing in the end. And it ends up being about
196.6, which is pretty close to the 196.2, but it is a little larger, which is good because it's the hypotenuse, and we've got that little itty bitty tiny angle.
And it should be. It should be a lot large, or it should be larger than this one. One thing you could do is you could check by using Pythagorean theorem. Okay, now these are rounded answers, so it's not going to be exact. Another side note is if you're given one of the acute angles in the right triangle, could you find this angle and use this acute angle to find the missing sides?
Yeah.
You could. So other options, and so something to kind of keep in mind if we do another one like that, which we are.
All right. So for this next one, it says, find the values of m and p and round to the nearest tenth. So take a look at what we've got here. We know we've got an angle, and it's an angle that's 57 degrees. And we know that we do for sure have which value?
The hypotenuse again.
The hypotenuse. So we know if you are given the hypotenuse, what ratios use the hypotenuse within them.
Oh, we didn't get the hypotenuse last one. Sorry, I said again.
Oh.
We can use sine or cosine.
Sine or cosine, because sine compared the opposite over the hypotenuse. So we have that hypotenuse piece. Or cosine, we know, compared the adjacent and the hypotenuse. Since we're given the hypotenuse, those are probably the two things I'm going to use to help me find those other two missing pieces. All right, so which one do you want to do first?
Let's find m first.
Sounds good. Comes first alphabet.
Yeah.
Sounds great. Okay, so which trig ratio would I want to use with my 57 to be able to compare the m and the 9?
Well, the m is adjacent, so that would be cosine. So cosine of 57 is equal to m over 9. And guys, I love that she first narrowed down which even trig ratios are even possible. Tangent ratio would not be logical here, okay?
Right. Okay, so again, we can think of this as a proportion. We can cross multiply. Here it's kind of nice because just m is equal to
whatever 9 times the cosine of 57 is.
And what does that approximately give us?
And that is approximately 7.5.
For m?
Oh, no, m, 4.9, sorry.
4.9.
And that wouldn't make sense. Okay, so to find p, I'm thinking it's opposite of 57. So I'm going to use sine because I have the hypotenuse as well. And we had already determined earlier.
These are the two trig ratios we could use.
Okay. We could use tangent ratio, but we'd have to use the value of m, which is a rounded answer, and we don't want to do that.
We don't want to do that.
Okay, so I'm going to set it up. Sine of 57 is equal to p over 9. And then we could easily do a little cross multiplying. Or if you think about it, guys, you could just multiply each side by 9. Okay, basically would be. So 9 times sine of 57 will get you what p equals. And p will equal about 7.5. Now, before we move on, notice if you look back at the picture, so m is 4.9 and p is 7.5. Notice both of those values are less than 9. That's a good sign because those should be smaller. And I notice I would anticipate that side p being larger than m because it's across from an angle of 57. And the other adjacent, or the other acute angle should be 33, and that is a smaller angle. So the sides across from it should be kind of in relationship to that.
Awesome, and that's a great relationship to see too.
Okay, one more concept, angle of elevation, just a vocab term. All right, it kind of sounds how it is. It's the angle that your line of sight makes with a line drawn horizontally. So kind of imagine if you're standing and looking up to the top of the building, okay? So that would be kind of you down here, okay? Draw a little stick figure. Okay, so you're looking and this is the horizontal with the ground. When you look up to see the top of the building, this is your angle of elevation. So angle A is your angle of elevation in this picture.
Makes sense. Sure.
Okay, so let's apply that. Same picture. So you're measuring the height of a building. So we're trying to figure out how tall that building is. And this isn't an indirect way of doing it. We talked about measuring things indirectly in Chapter 8 with similar triangles.
Right.
You're standing 100 feet from the base of the building. So if I was looking at this picture, what would represent 100 feet?
Well, that's how far away from the building. So segment AC is how far away you are from the building.
Okay, so 100 feet. You measure the angle of elevation from a point on the ground to the top of the building to be 48 degrees. So which angle would be represented by 48 degrees?
Angle A, because that's going from starting at that base, looking up to the top, that angle that's formed.
That angle of elevation.
Angle of elevation,
Good.
Exactly.
All right, it says estimate the height of the building. Now, when they say estimate the height of the building, that usually means we can round, okay? So, and then they don't tell you how to round, so this is where we're not going to be picky about it, okay?
Okay.
So, if we're asking for the height of the building, what would that be represented in this picture?
That would be segment BC.
So, this is your height. I'm just going to call it H for height.
Sounds great.
All right, so something to notice, it's a right triangle. We only have one of the two sides given, so you can't use Pythagorean theorem.
Right.
Is it a special right triangle?
Not a special right triangle. 48's close to 45,
so then
but
that means we have to use trig.
Okay.
Okay? Trig's going to be our go-to. Now, the question is, which trig ratio?
Well, I know from the 48 degrees, since that's the one I'm given, I'm going to use that one.
Okay.
We're looking for the opposite, and we have the adjacent.
Okay.
We don't have a hypotenuse here, so I'm thinking tangent.
Good deal. We're going to use a tangent ratio here to find that height of the building. So how would I set it up?
That the tangent of 48 is equal to the opposite, which is h, over the adjacent, which is 100.
And guys, again, she mentioned this is the angle that you were given. You could always use this angle and find it. It would be 42. But you would still use tangent, but you would use tangent of 42 and set it equal to the reciprocal of that. Remember, the reciprocals of each tangent ratios are happening in one triangle. So either way, it's going to get you the same outcome. That's what's kind of cool.
Right.
All right, I'm going to stick with what you have here. So essentially, if you want to think of it as a proportion, or in this case, just multiply each side by 100. So you have h equal whatever 100 times the tangent of 48. And we're going to estimate.
So it's about 111.06 feet.
Now, does that make sense? Let's think about, does this make sense? Real quick.
Okay.
Okay. Notice in relationship to the other leg that's given, what do you notice?
They're pretty similar.
And why are they pretty close?
Well, because it's about 48 degrees, which is close to the 45, 45, 90 triangle.
But it should be larger than the 100 because it's larger than this 42.
Makes sense.
So just kind of double checking things.